guys? Happy 2021. It's been a minute since I posted. Um, Happy to be back. Happy to be here. Get another video at Mr. Answer 414. And today we're going to talk about inequalities. So inequalities and equations are very similar. Equations talk about when things are equal, and inequalities talk about when things are not equal. When you think about your life and you think about the world, I'm sure you can think about a lot of times when things were not equal, when things compared and were different. So let's just hop right in. All right. Solving inequalities. I put this little alligator there because a lot of you guys, your first time seeing it was probably like in like first grade or something. I know I remember like first grade, something like that, and they talked about the alligator wanting to eat the bigger number. That was inequalities. Um, so, think about where you see inequalities. Is it in, the community? Is it in economics? Is it in the classroom? Is it in sports? Is it in funding for different football fields? Is it in quality of football teams? Go Packers. Quality of basketball teams? Go Bucks. Chicago got handed to them this last weekend. Sorry if you're a Chicago fan. Um, but there's a lot of things that are, better. Like you could easily say something like, my math teacher is greater than anyone else. Where's the lie? I don't know. And in math, I mentioned the alligator, but where else have you seen inequalities? I'd love for you to kind of pull out some of that pre-knowledge, some of that stuff that's already in your brain. So the working definition of an inequality is here. We're comparing. It's a comparison between two values. So is one less than, greater than, equal, not equal? We're just comparing two things. Some laughs. Maybe that stimmy hit for any of y'all. All right, so we got some examples here. I wrote 4 different examples, 1 and 2 and 3 and 4, and we'll talk about each of them real quick. So you could use this situation that I want you to complete at least 7 ALEKS topics per week. You define your variable, and you say the inequality here. A is greater than or equal to 7. It's greater than or equal to 7. And the Packers will stop the Bears from scoring more than 20 points. So they will score less. So if P is the number of points, P will be less than or equal to 20. So it will not be more than 20, but it could be 20. If I want to lose some weight, which I've been working on, dropping this COVID-19, and I'll make a little video on that one of these days soon. I need to consume less than 2,500 calories per day, and with C being the number of calories, that has to be less than 2,500. And if Giannis wants to improve his points per game average, he needs to score more than 29.5 points per game. So if P is the number of points, that inequality would look like this. P is greater than 29.5. So these are 4 real-world examples with the symbols, with the representation. Put this in your notebook. Maybe come up with your own. All right, this might be a little fuzzy. So we've got just the symbols of equality and inequality. Equal sign. We got all the different meanings, what they look like on the graph. So sometimes you'll have a closed circle, an open circle. The direction, so greater than, you go to the right, less than, you go to the left. Different vocab words, so you may see it read differently. These are all good. And then an example. And if it's a little, and I think it's good. So x equal to 2 is just a circle on 2. Greater than, this should be an open circle though, not a closed circle. So that should not look like that. This one as well should be an open circle, so it should not be shaded in. It should just look like this and just look like this. Possible solutions tells you the different numbers that would make this true. And again, I'm going to talk more about this, but this is a nice little cheat sheet. So I'd put this in your notebook right now. Pause. Just try to make funny faces when you guys pause, and then you can meme me or something. Somebody that knew to call memes memes. All right. So what can we do with them? So we have solved, we've been working with equations for a minute, right? But we can solve inequalities. And what are we solving for? So solutions of inequalities are the set of all numbers. So the set is more than 1. So there could be infinitely many numbers that make an inequality true. If I say, I need all numbers greater than 1, 2, 5, 100, 1,000, a million, all of those numbers work, right? And then we can put them on a number line. So with an equation, we found the solution. Shout out Hannah Montana. He could be the one. But with inequality, we find the solution. So there's usually going to be more than one. Doesn't mean there always is, but generally it's the set of all solutions, and there's many of them. All right. So continuing with the set of solutions. So we have an example here. We've got the equation 2x equals 4. If you solve that, you divide by 2 on both sides, you get x equals 2. 2 is the value for x that makes the statement true. So if you have a 2, that's your number. That's the only number that makes that equation true. But in an inequality, if you have a very similar one, 2x is greater than 4, and you divide by 2 to solve it, you get x is greater than 2. So all the numbers greater than 2. So 2.1, 3, 4, 500, 5,000, 2.0001, any number possible that's just greater than 2 makes it true. 2 does not make it true because 2 is not greater than 2. It's a little more relevant to equations, but it made me laugh, so I had to throw those in there. Once you know the set of solutions, you can graph them. And here's a little swag number line that was on Google. That's very, man, they hating hard on Justin Bieber, though. I rock with Bieber these days. Okay, so these are definitely some clean examples. Put in your notebook. You got examples of inequalities. So we have x is greater than or equal to 2, and that's going to be a closed circle, and it goes to the right. X is greater than 2. It's a open circle because 2 does not count, because 2 is not greater than 2, and it goes to the right. The less thans go to the left. Bigger numbers to the right, smaller numbers to the left. All right, so let's do our own little examples here. So we have x is greater than 3. And when I make my number lines, I'm going to put 3 in the middle. And I like to go at least 2 numbers deep on each side. So 5 numbers is how I like to do it. X is greater than 3. So it's going to be a circle at 3, and then I ask, is it open or closed? Well, if it's equal to, it's closed. So this will be a closed circle at 3, and then we go to the right. I like going up and over because if you draw it on the number line, it's hard to read. So if I were at home doing this, and I'm trying to put something over, I might get a ruler, a phone, a flat edge, a straight edge, and draw my number line. Again, you don't need as many tally marks. If you want more, you can. But like for me, I like just working with 5. So I try to put the number that I'm working with, the solution, in the middle. And then I put 2 numbers on the left, 2 numbers on the right. Now with negatives, guys, somebody always messes this up. When you go to the left, you get more negative. When you go towards 0 to the right, you get more positive. So the numbers get smaller as you go to the left, and they get bigger as you go to the right. So in this case, you ask yourself, okay, what number, where's my solution, where's that like middle point? And it's at -7, so I'm going to put a circle. Then I look at the symbol. Is it greater than or equal to, or less than or equal to? And it's not. So this remains open because 7 is not a part of the solution. Now am I going to the right or to the left? To the left all day. Left all day. I think I'm going to let that breathe. I think that came across. More Kylo Ren, you can wait. We'll come back to that later. I don't need anything right there. All right. So solving. You can solve inequalities, and you solve them just like equations. There's one little case, and we're going to talk about that. To make that train track, figure out what to do to isolate the variable. We got to get y by itself, so I got to get rid of the 2, and I got rid of the 1. I'm going to get rid of that 1 by doing the inverse operation. Nice little equation review. Subtract 1 on both sides. 2y is less than or equal to 6. And divide by 2 on both sides, and y is less than or equal to 3. Now what I like to do is I like to always write out possible solutions. Possible solutions, and I'll abbreviate that because I'm lazy. So what numbers do I know count as being less than or equal to 3? Well, 3 first of all, right? Because 3 is equal to 3. And then less than, so 2, 0, -100. They all count. So when I go up here and I make my number line, I graph the solution. I've put 3 in the middle and put 2 numbers on the right, going to be a circle at 3. I look at the symbol and it's equal to, so I fill it in, and then I go to the left. And all these numbers over here are all part of the solution. 2, 1, 0, -1, etc., etc., etc. All right, if you guys are feeling like you're getting it, this is a good time for you to start doing some on your own and then checking. But I'm going to proceed to solve it. I'm going to add 1 on both sides. 6 is greater than or equal to x. Easy money there, all day. Give it to me, give it to me. So it's going to be, now you got to be careful, you got to read it. So 6 is greater than or equal to x. Or you could rewrite this as x is less than or equal to 6. If you rewrite, it's okay, just make sure you put it in the proper order. So less than or equal to 6 is going to be a closed circle, and it's going to go to the left. Possible solutions would be 6, 5, 0, -5, etc. All right, so we got, I'm trying to go through all the different types of solving. So 5x less than 20, we have to get the x by itself, so we divide by 5. That's the inverse of multiplying by 5. So x is going to be less than 4. So the possible solutions would be anything that is less than 4. So not 4, but 3.9, 3, 1, -2. All those numbers, I could do -2.7. Fractions count too. So I'll put 4 here. 2 numbers in each way. Gonna go open circle. I'm gonna go less than. There we go. And your arrows, your lines should match up with your possible solutions. So if your possible solutions show you, they should show you where you're going. All right. This one's just an addition problem. So we'll subtract 6 on both sides. We get x is greater than 3. And again, guys, I'm really hoping that your solving skills are feeling pretty good right now. And so I'm not taking a whole bunch of time to talk about that. Open circle, and we're going to go to the right. And again, you could list the possible solutions. All right, now here's the thing. This is importante. There's one special rule that you have to do when you're solving inequalities. If you multiply or divide by a negative number, you got to flip the sign. So if you had a greater than, it now becomes a less than. If you had a greater than or equal to, it now becomes a less than or equal to. You have to make sure that you make that happen when you multiply or divide by a negative number. So if you do something like this, and you divide by a negative number, that's what you're looking for. If that 4 was negative and the 2 was positive, it doesn't count. It doesn't count. You got to divide by a negative. But seriously, when you multiply or divide by a negative number, you must flip the sign. You must flip the sign. You must flip the sign. I'm telling you. People forget this every year. Write it down. Because yeah, it matters. Like x greater than 2 is different than x less than 2. X greater than -2 is different than x greater than +2. So we have to go through it. If I could talk more about it later, but just write it down. You'll be good. So let's do a couple real quick to solve it. Subtract by 4 on both sides. We get -2x is greater than 8, right? And then we divide. Now look we're going to divide by a negative. And if you divide by a negative, you got to flip the sign. And I already messed up because I'm going too fast. What's wrong with you? All right, so because I divided by this negative sign, the inequality sign is to flip. So it's no longer greater than, it's now less than, and it's -4. Because if I didn't flip it, right, this is bad, so don't do this, but if I didn't flip it, it would be x greater than -4. You see how that's completely different. Completely different. And then if you put a number, and this is how you can check it, if you put a number that's greater than -4, so let's say you put -3, and you put it into your solution, into your original equation to check the solution, you're going to find out that that's not going to hold. So if you put -3 in, you're going to get +6 plus 4. Is 10 greater than 12? Nope. So that's your way to check. If you are unsure if your inequality sign's pointing the right direction, check your answer by substitution. So we get -4, -5, -6. Oh, what am I doing? Tripping. I gotta take a breath. My daughter got Elmo Wears Masks. It's a book about Elmo wearing a mask to school, and he gets nervous and he has to take deep breaths. So that's your reminder to breathe today. And it's going to be an open circle, and it's going to be less than, so it's going to go to the left. Bam, bam. We'll go ahead and, this is a good opportunity for you guys to pause and try on your own. I will show you how this works. I'm going to subtract 20 on both sides. I'm going to get -30. is greater than negative 5x. Now, that negative 30, it doesn't matter that that's negative. What matters is that this is negative, right? So we're going to divide by a negative, and that tells you that your sign is going to flip. So flip it right away so you don't forget. Negative divided by negative is positive, and x is greater than 6. X is greater than 6, or 6 is less than x, whichever way you want to see it. 6, 7, 8, 5, and 4, open circle, go to the right. Bam, making that money. I'm serious. You're going to forget if you don't write this down a bunch of times. At least 7 times. Write it down and say it. If you multiply or divide by a negative number, you got to flip the sign. If you multiply by a negative number, you got to flip the sign. And when I see you guys next week, I'll make sure you say this in class. Because if we were in person, I'd make you yell this so everybody down the hallway can hear you. Big facts. This is just division. Now, we're going to multiply by 3. We're going to multiply by 3. X is 24. Now, what do I do with the sign? Did I multiply by a negative number? I did not. So this doesn't change. If this was this problem instead, definitely would have flipped the sign. Definitely, but it wasn't. So in this case, you have that negative x. This tells you all you need to know. You're going to multiply by that negative 2. Stack that paper, guys. For real. Don't forget. All right, so let's recap inequalities. So the solutions to an inequality, it's a set of numbers. It's not just one number like an equation. There's 4 different symbols. I want you to be familiar with them. I want you to know what they mean, which way direction they point, what the circles look like on a number line when you graph them. You can graph and solve them. If you multiply or divide by a negative, you flip the sign, and you solve inequalities just like equations. Guys, like I said, it feels good to be back making content. I took a nice little break. Hopefully you guys had an amazing break. Let's start 2021 off seriously in a beautiful way. I'm going to get this video edited in a minute. I'm going to drop it online. I'm going to see you guys soon. So thanks for watching. Again, it's at Mr. Hanson 414. Hit that sub button. Hit that like button. Share this to your friends. Let's get it. See you guys later.